The graph to the right describes the relationship between velocity and time for an object moving, for a moving object. So we're going to use this to solve the remaining problems. This is probably a good time to start talking about graphing issues. All right, so if we look at three graphs and we plot position versus time, and velocity versus time, and acceleration versus time, we know the units for position are meters. For velocity, it's meters per second, and acceleration, it's meters per second squared. So we can just put some sort of lines on here. All right. And what we know, two things we have to remember. Area and slope. And if you remember that area starts with an A, and A points to the beginning of the alphabet, and slope begins with the letter S, and that kind of points to the back of the alphabet. This is an easy way of determining which slope you'll move to. So let's see, in our last problem, this is a velocity versus time graph. So a velocity versus time graph, which would be this type of graph. So if we want to know a position or a displacement, that's this type of graph, we would have to move to the left, which means we would need to determine the area to get the position off of a velocity versus time graph. If, on the other hand, we wanted to determine its acceleration off of a velocity versus time graph, we would have to find the slope of this line to determine its acceleration. All right, so let's go back to the problem. Number 13, what's the acceleration at the time of t equals 1 second? So to get the acceleration, we want acceleration off of a velocity versus time graph. So velocity versus time, to get the acceleration, we need to find the slope of that line. So the slope of the line at 1 second would be the slope of this. We have a rise of 4, and we have a run of 2. So our acceleration would be 2 meters per second. For number 14, what's its acceleration at 8 seconds? Well, again, we need to find the slope, but this time at 8 seconds. And we can see the slope at 8 seconds. There is no slope, so its acceleration would be 0 meters per second squared. What's the acceleration at 6 seconds? So the acceleration at this point. So we can see the slope of this line is constant. So at 6 seconds, we could just say, okay, what's the rise and run? Well, the rise at this point would be a -4 over a run of 1 second. So it would be -4 meters per second squared. Number 16, what's the total displacement? All right, so now what we need to do is find displacement. Let's get rid of some of this stuff here. Displacement off of a velocity versus time graph. So velocity, displacement off of a velocity versus time graph, we have to move to the left, which means we need to get the area. So looking at our graph, we need the area, and they want the area for the entire trip. Okay, so let's break this up into segments. Yeah, that's not working too well. Let's do it this way. So the area of this triangle would be half the base times the height. which is half of 2 is 1. 1 times 4, so this area would be 4 meters. This next section here would be a rectangle, which would be length times width for area. So from 2 to 5 is 3. 3 times 4 would be 12. And this next one here, half of the base, well, we could say from 0 to 4, we could call the base, so that would be 2 times 1. So its area would be 2. Down at the bottom here, this area would be the same, but it's negative 2. Our next little rectangle would be this area here. And we have 2 times 4, so that would be a negative 8. And the last triangle, we have half of 4, which is 2 times 1, would be a negative 2. And we know that displacement now, total displacement is a vector, which means it has magnitude and direction. So we could add up okay, so if we total up this, 8 plus 2 is 10, plus 2, so this is a negative 12. So that negative 12 would cancel out the positive 12, and we're left with a total displacement of 6 meters. And number 17, what's the total travel distance? Our total travel distance, we know d tot equals d1 plus d2 plus d3 ... So we don't really care about distance is always a positive. It's negative, never a negative. So what we need to do in this case is we need to total up all of our distances. So we have 4 plus 12 plus 2. That would be a total of 18. And a total of 12 here. So 18 plus 12, and we're going to have 30 meters. Number 18, between what times does the object approach the origin at a constant speed? So we need to approach the origin at a constant speed. Let's get rid of some of this. All right, so if we need a constant speed, we know off a velocity versus time graph, the slope of it is going to give us our acceleration, and with a constant speed, acceleration has to equal 0. So we would need a slope equal to 0, which would be this portion of the graph or this portion of the graph. Well, we can see at the first portion here that this has a positive displacement, meaning we're moving away from the origin. This one has a negative displacement, which means we're returning to the origin. So the best choice would be from, looks like 7 to 9 seconds would be our best choice. Letter C.